Data centers in space has been a hot topic in the last few months as a potential future solution to the limitations of running massive data centers on Earth. Ramon.Space, which builds edge computing and onboard processing systems for satellites, has been preparing for this future for years. In this episode, Ramon.Space CEO Avi Shabtai shares the concept of a distributed architecture for data centers in space, where many satellites act as nodes in a mesh network. He envisions a fleet of satellites to form a large data center, where each satellite is capable of providing computation, storage, and other capabilities. In this episode, Avi explains the tech behind the headlines and shares his predictions for how data centers in space might take shape over the next 5 to 10 years. I'd like to thank Ramon.Space for sponsoring this conversation. I'm Rachel Jewett, and you're listening to On Orbit, the podcast that asks, what's our future in space? Hi, Avi. Welcome to On Orbit.
Hi, Rachel. Good to be here, I guess, again.
Yes, I think you were on the podcast a couple years ago when Jeff was hosting.
Yeah,
So
thank you
welcome
for
back.
good.
Look,
Nice to be again.
yeah, so I'm excited to have a conversation with you today. We're going to talk about data centers in space, which has been a really hot topic in the news lately. But before we get started, just introduce yourself to the listeners and talk a little bit about your work at Ramon.Space.
So I'm Avi Shabtai. I'm the CEO of Ramon.Space, and I guess leading this company in the realization of computing infrastructure for space. It's been an exciting journey so far, and I look forward for the next steps. As I see in the industry, I guess more and more computation that is done in orbit, and that's what we aim to do.
Yeah. What year did you start the company?
So we started the company in 2020 as I would say the initiative of computing infrastructure for space. We do have a history behind that of developing radiation hardened semiconductor for space. And I guess in the last 5 years, the focus was how do we bring the full span of infrastructure of computing into orbit? And that ranges from storage systems to processing system to connectivity systems, pretty much whatever you can do with data, right? That's the three elements that you can do with data. And the integration of the three of them actually enables to build all sorts of edge compute to data centers in orbit.
Space, the ultimate edge.
Exactly.
So, data centers in space have been a major topic in the tech industry in the last few months. I feel like it's been buzzy even outside of the space industry. And part of that is Elon Musk has talked about funding data centers in space as part of the rationale for SpaceX to go public. From your perspective, why are data centers in space becoming a key target for both the space and tech industry?
So I think that the concept of data center in space has been cooking, I guess, at the back burner for a few years, right? And I think the initial path was really the fact that more and more data has been generated in space. And once you have more data that is generated, then you need some way to start dealing with it. And when we call it computing, and then we realize that in a terminology of, okay, let's build data centers. Now, data centers have all different shapes and types, and we can discuss that. But that I think was I would say the initial idea. Okay, why do we need certain massive computing in space? And I think this path was quite clear to begin with a few years back. And we've been pitching this story, I guess, for the last definitely 5 years. And I think what happens lately, it actually combined with another trend that we're seeing, which is the limitation of the resources on Earth to support the continuous growth of computation, right? As we're seeing AI inference needs are growing, and there is not enough, the expectation that there won't be enough energy on Earth. It's not going to be efficient, and at some point of time we will need to start finding other resources and other, let's put it in the geographies where we can start putting these massive data sets. So I think those two trends are joining now forces, and we see that part of the communication of Elon and others. How do we start putting more and more assets in space to support these two trends?
Yeah. You mentioned the growth of AI is part of what's fueling this conversation. What are some of the challenges with data centers on Earth, like some of the limitations and why people are looking to space?
Well, looking to space because of, I would say, I mean, the limitation of Earth, of course, are known. It's energy, it's real estate, it's the ability to cool systems, um, and of course, the carbon footprint that this, amount of energy creates. The other point, which is a limitation for actually the space assets, is accessing these sources of computation of AI on Earth, because any satellite in orbit has limited time when the satellite have connectivity to an asset on Earth, and there are the logical limitation of bandwidth and delay in terms of receiving the information. All this leads to certain limitation that you start to look into how can I bring it closer and how can I do it actually outside of the terrestrial networks. That's how I see, the main limitation on Earth. On the other side, of course, it's not easy building this type of infrastructure in space because of other limitations in space as well.
So then what would data centers in space look like and how would they function?
Mhm. Yes, and I think it goes back to what I mentioned before, because when we say the word data center, some of us may envision something that they see on Earth, or sometimes it could be a football stadium size of a warehouse where you have computers and servers. But I think that the data centers in space will go more into what I'm calling a distributed architecture, where we will have many satellites orbiting Earth, and each satellite will be a node where you would have computation and storage and maybe other capabilities. Then the connectivity between these satellites, this mesh connectivity between satellites, will be kind of a switch fabric of a much larger data center. So virtually the fleet of satellites, this constellation of satellites, will become as one large data center. I think that's kind of the real realization of data centers in space. Maybe down the road, fast forward a few years from now, then we'll maybe start seeing larger data centers in orbit. But I'm pretty sure that the first realization will be in what I'm calling a distributed architecture.
Okay, so like a constellation that functions as a data center. That's really
Exactly.
interesting.
Yeah, yeah, yeah. And there are many advantages to this architecture because you've got the built-in redundancy. The architecture, which is built from a constellation, gives you immediate coverage to any point on Earth. You don't need to, look for a connectivity because you have a constellation that covers all of Earth. Then you can grow by adding more nodes, right?
Mhm.
And you can also have not all nodes must be the same. You can have nodes that are more focused on one task, or other nodes are focused on a different task. So it kind of opened the door for really looking into a very, very, I would say, creative way of building this type of infrastructure.
Mhm. I also see, so you had mentioned that there's demand for more computing in space and there's demand for more computing on Earth in the data centers on Earth. Um, Sounds like this disaggregated architecture would be really beneficial for other satellites in orbit collecting data. Can you talk about how it would serve like other satellite customers?
Well, once you have a computing infrastructure in orbit in a form of, let's call it a data center, it means that you have many nodes in orbit or a network in orbit you can access. So just imagine now that every space asset can access this massive computation capability immediately at any given point, in orbit, get all the resources, get computation. It can either enable other satellites to be more efficient, to get real-time data, to share real-time data, maybe to offload some of their heavy computation to to the network itself. So I think it really opens the door for many ways where you can start using this infrastructure by other satellites. We've been working in the last few years on building all these different parts of what I'm calling data center in orbit. I mean, we've been working on building storage system, computation system, connectivity system, all of which, can be combined to build a data center. And we were discussing in many of the cases, we're discussing it with what I'm calling application specific satellites, right? Those that want, let's say, remote sensing or imaging or communication. And we can see how a network that combines all the capabilities can help them a lot to optimize their satellites in terms of cost, in terms of the lifetime in orbit, and in monetizing the satellites in a much better way than they do today. So at the end of the day, it can impact their business model, their ability to operate, how they get more customers, and how they can deliver more with the assets that they have.
What would these kind of data center satellites, what would they look like?
It's a good question because what does a satellite looks like, right? It's got solar panels. I'm calling it's a tin box with solar panels, right? The question is not what the satellite looks like. It's more about what does it look from the inside. And that's the big change because if you would open that box, so in the past you would see analog components, RF components. Suddenly you open it and you see the creme of the creme of computation capabilities, right? You start seeing massive storage, you start seeing AI machines, you start seeing like the things that you would see on Earth in either edge compute or data centers, and that's the important part. So the satellite will look similar. It will have solar panels, it will have antennas, it will have optical connectivity from the outside. What's important now, it's what does it look from the inside? And the inside is going to be those big, massive computers with storage that will change what the satellite is actually doing in orbit.
Yeah, absolutely. And I understand there are some challenges with that type of onboard computing in space because of the space environment. So, can you talk a little bit more about those challenges and how they might be solved in the coming years?
Yeah, so I think there is, from one side, we need to take technologies and deploy them into space. So deploying technology into space mean you have, first of all, to stand with the space environment, right? You have to deal with radiation. You have to deal with sometimes extreme temperatures orbiting Earth. There is a transition between extreme temperature every time you orbit Earth. Vacuum environment and alike. So these are, I would say, the common uh, space-related issues. Uh, but I think on top of that, you have to make sure that when you deploy something in space, you know, we have to make sure that the size, the weight, the power consumption elements that are becoming so critical when you put them inside satellite should work to the level that you can actually operate effectively these computation machines, right? So there's special attention to how much power is being consumed, to how you make sure that the size is condensed. This will become very, very important, especially for those units. I've been talking to people that are operating and building data centers uh, on Earth, and one of the topics that was discussed is that it requires a lot of sometimes human maintenance because things are, you need to replace. We need to make sure that, I mean, there's no customer support that is coming to the satellite and replacing cards. I mean, we have to make sure that it works and it's going to be reliable for the duration of the mission, which could range between 5, sometimes maybe to 15 years. So that's not easy to implement and to launch into orbit. So we will need to cross those barriers when we realize this type of infrastructure.
That's a really interesting point you bring up that the satellite it can't be serviced in the same way, at least now that the data centers on Earth are. Can you tell me a little bit more about the conversations you've had with data center companies on Earth?
Yeah, I can shed some light on that. I think it goes in line with what we mentioned before, that many are not looking to replicate exactly what they see on Earth in space in terms of, okay, I have this warehouse, I want it in orbit. No, they're actually, they understand that the architecture may need to be different, and also the use cases may be different. It's not going to be this, it's not the same type of use cases. But I think what's interesting is that they also see some kind of a fusion between the two networks, the network in orbit and the network on Earth. So some tasks would be more efficient if you do them in orbit, and then some tasks would be done on Earth. So I'm seeing a lot of I would say collaboration going on between the data centers on Earth and data centers in orbit.
Yeah, that's really interesting. And then you've talked a little bit about how Ramon is building all of the pieces of this, but I want to have you talk a little bit more about how Ramon Space is kind of how you guys are positioned in this trend.
So I think if you look at what we've done in the last 5 years and even before, it is really we looked at from day one we looked at the market that the market will evolve gradually to do more computation in orbit. And then we realized that we have to bring all the elements that deal with data. I mentioned them: storage, processing, and connectivity. And then what we're doing today is like bringing all of these elements together to offer solutions that will enable customers, as we mentioned before, to open that satellite and put inside it a major data center that they can start operating in orbit. And then if they have multiple of these, we basically enable the build out of a mega data center in orbit. So I think our position is to really enable the whole industry, anyone that wants to build this type of infrastructure on, to be able to build it. It could be ranging from, the enterprise market, sometimes towards governments that want to build this type of infrastructure in orbit. We don't see ourselves you know, as a vertically integrated player, I mean, in that sense, because we want to enable the whole industry. We want that the industry will have the diversity of data center. One data center will do one thing, the other one will be focused on another, servicing maybe other type of customers and a different optimization point, which is very different, I guess, from someone that is vertically integrated, that, they're more attached to their fleet, to their type of satellites, to their type of customers. So the position of Ramon is really to be, we're a pure play, independent player that wants to enable the whole industry to build this type of solutions.
Interesting. What's your prediction for how data centers in space might evolve over the next 5 to 10 years?
I
And
see a big difference
what we'll
between,
actually see in orbit, I guess, is my question.
yeah. So I see a big difference between the 5 and 10. You
Hmm.
know, I would say that in the first step, we will start seeing deployment that ranges from edge compute type of satellites towards the initial distributed architecture of data centers. That will be probably in the range of 5 years. I think that 10 years from now, we may see massive computation in orbit, meaning it's going to start being an alternative for Earth's computation. And when you look at it from the right angle, I mean, there's no real reason to perform all the computation on Earth, besides the fact that we live here and it's accessible by us. I mean, if you could build everything out and have the right sources of energy and make all this outside, it's probably, let's put it in the brackets, a bit healthier for us to have it all there and just use the resources. So think about the way, I mean, we're using solar energy on Earth. We can use computation energy from the outside on Earth as well. So I think this is more towards the 10 years. In the first 5 years, I would start seeing these distributed architecture data centers in orbit, and starting to see the applications that use this infrastructure, which will, I guess, drive the build out of more and more and more capabilities in orbit.
Yeah, absolutely. Oh, super interesting. It's a future space application that's it's sometimes when we talk about the future space economy, I feel like it's things that maybe aren't directly wouldn't have a direct benefit. Like maybe people might need it in the future, but this is something that would really be a benefit to Earth right now. That's,
Yeah, and we've been asked many times about applications, and applications, and I'm saying the way I look at the smart people that work in our industry and adjacent industries, I'm saying there are enough ideas that come out of what to do when you have a computation power.
mm,
And I believe that there will be services and applications that we don't think about today that will utilize this infrastructure. I see our goal is really to build that infrastructure or to enable that infrastructure that actually will enable a huge industry to follow up on and to use it for, commercial benefits, for, mankind benefits, if you want to look at it from this point of view.
yeah, absolutely. I want to ask a little bit more about Ramon Space. What kind of demand are you seeing, and how are you seeing it change for Ramon Spaces, your edge computing and onboard processing systems?
So what we are seeing, I'm seeing in the last, I would say, really 24 months is a huge. I mean, we started with bringing to the industry computation capabilities, and we're seeing in the last 24 months, really, it's a huge transition in the demand for digital satellites and more computation in orbit.
Mhm.
And kind of everything we invested in starts to be actually used by customers. And for us, it's amazing. I mean, a lot of the thoughts that we had back then 5 years ago are becoming a reality now. So we got an amazing market traction. I think we're seeing ourselves really at the front of enabling that whole industry with digital capabilities, software capabilities, and the realization of making those satellites much smarter than what they used to be. And I think it's a fascinating place to be in. I mean, we are impacting the whole industry in this transition, and being at that, at the edge of that is exciting. Is exciting.
How much has the company grown over the last few years?
Yeah, well, it depends what you call grown because I mean, we've started in one location. Today we have actually four locations around the world, Israel, US, UK. Soon we'll have really another one. We have operations running from Asia all the way to Europe to the US. Um, we probably more than tripled in the last 24 months in
Wow.
terms of the number of people. And I think the market traction has been amazing. Even without going to the numbers, I think we're doing very well.
Well, Avi, this has been a really interesting discussion. I've learned a lot because I've been hearing a lot about data centers in space, and it's interesting to think about the future of the actual, physical computing centers, but also this disaggregated, like a satellite network that's performing the function of a data center in space. So thank you so much for coming on the show. Do you have any final thoughts as we wrap up?
So final thoughts. So first, really thank you for the opportunity to speak about it. I think that for me, it's an opportunity not just to tell the story of Ramon.Space, but really to open up a window for people that are, either in the space or sometimes not out of space, but out of space industry, and to tell them about something really big that is going to happen. Now, I'm meeting a lot of people that are telling me, "Oh no, this is never going to happen. This is just dreams." And what I realized is that sometimes you have to actually look into something in more details to understand why suddenly things are possible. And sometimes when you just look at something from the outside, you don't really understand it makes sense, doesn't make sense. So for me, it was an opportunity um, to help other people to look into it from maybe different angles, So they will realize that we are going in this trend, and I hope that at the beginning of next year, we'll have another opportunity to talk, and we'll look back and say, "Wow, look, look what happened this year that actually we thought will happen." And really, that's the opportunity, and that's my thoughts. It's a real opportunity to tell everyone about things that are going to happen.
Yeah, it's a very interesting, evolving area. Well, thank you so much, Avi, for joining. It's been great to talk with you.
Thank you, Rachel.